at least a draft of a best practice document, but hopefully like a really solid version 1 that we can start then building on in future years as our research improves. So thank you very much, Richard.
Thanks. Hello, everybody. It was a while back, 20 years ago, I did my PhD here at what was then UPE, and then left the province after finishing and ended up working in the Drakensberg and have just stayed in KZN for the last 20 years. And I suppose that put me in a fairly unique position in that I did have a good ecological understanding of the thicket biome and whatever goes on inside of it, but I also was removed something of the politics and polarization and relational things that have emerged over years, just because people are that's who we are as people. And so I've come in and in some ways tried to find a way to bring a body of science, because there's been a huge amount of work. Many of you sitting here today have, over the last 2 decades, contributed significant steps forward in the science. And what I've tried to do is pull all of that together, coming in a little bit as an outsider with no agenda in any way, to pull it together on the basis of what can we really say about the biome, the ecology of the biome, and with a particular focus on restoration. So there's obviously a lot of momentum that even started 20 years ago with the subtropical thicket ecosystem program STEP, and then from that there was the subtropical thicket restoration program, STRP, I think it's right, and a lot of momentum has come, and then I think in the last few years this growth in the carbon markets has come, and there really is, like, honestly, my gut feel as somebody just who observes life and knows a little bit about science, we're like so poised for a lot of momentum in the province. And Tony spoke, ended his talk speaking about a community of practice, and really the time is ripe to pull together now, and to, I think there in a sense is, a lot can happen in the next few years. Incidentally, this is a difficult session to talk to. You all had lunch and all the rest of it. I also teach science to high school children. I have 40 students that are homeschooled kids, and I teach them all science. So I've learned a few tricks in keeping people engaged. One of these is, if you ever are a teacher, it's a great trick. So I have a bar 1 here. Somewhere in my talk, I'm going to deliberately mislead you. There will be a false fact. And if you can get the false fact, you get the chocolate. So, it's a great way. I have these kids that hang on to my every word, try and pin me down. Sometimes picking out 2 or 3 false facts where you've made a mistake. And right, so, does this thing actually work? I don't want to point it that way. There we go. So, you would know maps like this well, where we've got the black would be the thicket biome, and everything other colored is not thickets, it's other biomes, these 7 biomes that people have spoken about. And we've got this remarkable situation in the thicket area where thicket has these incredibly diverse and interesting gradients into these other biomes. So we can move into the savanna biome up here, and the grassland over there, and the Nama Karoo, a big swath of it there, and fynbos and succulent Karoo along this side here. I see yellow and green are remarkably similar. So that is yellow, it's fynbos, and that's green, and that's grassland. And so we've got these gradients into other vegetation types, and I try and imagine over the eons of time, however long this has been like this, this biome expanding and shrinking and moving subtly across the landscape as it's responded to the major environmental climatic drivers. And we look at it now in its sort of current position here, but I think it's moved around quite a lot, and there's been these interactions and shifts over the years. And so what we see is we start to get some pattern that pulls out of it. Firstly, we see that there is a gradient of mean annual rainfall. It's a very weak estimate of moisture availability, but there it is. And we see, generally speaking, it moves drier into the interior from the coast. That's just one arrow, but there would be several arrows like that. And then related to that, we've got rainfall seasonality. So you've got the winter rainfall zones down here, switching slowly through to a more summer-dominated rainfall, quite different rainfall patterns, but with very significant implications for moisture availability, where you have a hot, dry winter in this part of the world and a wetter, hotter summer over there. Quite a significant driver of ecology when your moisture availability is. And so we get that shift into the succulent Karoo and fynbos down here versus the grassland and Nama Karoo and savanna up in the northeast there. Whoa, that was a little excessive. This thing's a little jumpy. Right, and then another one is the variability of rainfall, the coefficient of variability. How random, how unlikely is it that you could predict rainfall? And that, again, becomes more and more variable as you move inland from the coast. So the bottom line is, if you are making a living over here as a plant or an animal or a farmer, you've got an unreliable low rainfall that occurs in your cool season, leaving you with a very hot, dry summer, and it's very unpredictable. Any 1 year could be a drought year, and it's quite a harsh environment to live in. And then superimposed on that is this incredible diversity of finer scale disturbances and patterns. So we have an incredible topography. I mean, if you guys know this area well, but all of these mountain ranges that occur over here give rise to intricate topographic variation and subtleties that moderate the microclimate, and there's incredibly complex geology giving rise to layers of shale and sandstone and other types of rock. What would be another type of rock? Like the volcanic rocks. Those ones. Dwika and not Dwika. Thank you, Dollarite. It was there, but I actually do know it well. But there it is. And now I was going to say, yes, so we got this complex pattern. And then on top of that, we've got disturbance. You think of the indigenous herbivores, and then the arrival of mankind, not mankind, Europeans with the settlers in the 1820s. That's not the false fact. And then I've just finished reading Denese's Rate's Commando, his book Commando. I don't know if any of you have read it. He was one of the Boer War. He wrote a journal of the Boer War, the Second Anglo-Boer War. And him and under the leadership of General Smuts spent some time in these mountains in 1905, and he describes what they did on those farms and how settled the area was. We can't really understand the weight of history of this disturbance of herbivory. I think we sometimes get stuck in our minds that we think back in our lifetime or even our father's lifetime, that's in a recent history. But actually, this area has been subject to so many years of it. These disturbance patterns give rise to a complex, the point I'm trying to make, somewhat laboriously, is its complex subtlety here in the thicket biome. So we end up with this pattern where we've got a solid red, the solid types of thicket grading from the mesic to the more albany to the more arid forms. But even within that, there is lots of arid even over here. It's not just a general pattern because of the complexity of topographic variation. And then in the light beige color, it would be we go start grading into the other biomes in these complex mosaics. So that's all good and well, but now we seem to often get stuck on this word degradation or transformation, And that literally is something that right from my PhD in 2003, we were wrestling over this thing. You know, the bottom line is, I really will stand on this one quite firmly, is that if you read the restoration literature, they're very clear about, in the modern treaties of restoration, that degradation is well defined, and it is determined by if you can say on any of these factors, biodiversity, habitat, biomass fodder, primary productivity, soil protection, climate amelioration, nutrient cycling, carbon restoration, sequestration, rainfall efficiencies, infiltration, like any of these factors, if you are picking up a decline over time, you are dealing with degradation. So I must say, as a scientist, I understand there's sensitivities around language and all the rest of it, but I think we must be open to calling it what it is when we look at the state of vegetation around us and the state of the thicket ecosystem. And to a large degree, I would say we're just dealing with degradation. Transformation has other language meanings, and I'm personally become very comfortable just to call it what it is, degradation. And that's really what we've seen is this change over time. So the question is, how do we, as people who are interested in restoration and the rebuilding of an ecosystem, how do we understand the process of degradation sufficiently that we can go back up? And a useful tool to do this is a theoretical framework called state and transition modeling, or state and transition theory, which is really quite simplistic. It's not hard to understand. And in its simplest form, it looks like this. You can have a state, a community that can exist. We're talking about a plant community here. It can exist in a certain state. Within that state, there might be subtle shifts of how that community would be responding to variation in the environment as the climate slowly trundles through whatever it's doing, or things are happening. The vegetation slowly shifts backwards and forwards, responding to its climate, to its environment. But you would define it primarily on the big factors of its community structure. How is it? What are the dominant species in there? How are the main ecological processes functioning? If those are all the same, you would consider it in a single state. However, it doesn't stay there. It can be pushed. You can transition a community where you're starting to pick up significant changes, particularly in guild structure, where you're losing whole guilds like trees or succulent shrubs or grasses or whatever you're dealing with. You start to lose a significant part of the community changes. You start to see that the ecosystem attributes change, the way nutrients are cycling, the way reproductive processes take place, feeding behaviors of animals and things changes, and all of that nature of change. That transition passes what we would call a threshold. In other words, if you can push a system, generally speaking, as you push a system and you're heading it down the arrow, we use language of resilience. You can say, well, if you push it to a degree, it'll bounce back. It's resilient. But at some point, you nudge it or you push it over an edge, a threshold, and it will not spontaneously bounce back. That's the definition of a threshold. It can't go backwards by itself. And then you start to end up in state 2, which would be significantly different. You would be not, shouldn't require specialist knowledge. A specialist, highly educated person wouldn't need to be called out to a farm to notice this change. To me, these are fairly substantial changes. And that's the basics of a state and transition theory. And restoration activities, the fact that we have to get involved as humans to undo damage and to go backwards in the process is the nature of restoration. That's what we do. Okay, sorry, big jump. Can you go back for me, please? One more? Right. So if we just look, this is how I've come to see thickets, having read through a truckload of papers and theses and things like that. I've tried to put it into a state and transition model that we can work with. We're still too far back. Go back one more and another one. No, not too far. There we go. Nice. Thank you. In its intact state, what I would call state one, we deal with this stable body of vegetation which is incredibly resilient to environmental change. It can handle major droughts. It's probably originated under quite a more favorable climate, and it maintains its own climate. And in doing so is able to buffer itself from the vagaries of Eastern Cape weather prediction. And it shifts under browse pressure to a second state, which I've called semi-intact thicket. But this is not a major state shift. This arrow is reversible. It will spontaneously recover under the release of the browse pressure. So I think herbivory is a natural part of the system. Obviously, there's a lot of animals that live here, and it can shift. The key here is that you're not losing individual plants, you're just losing biomass. So if you imagine a situation where a whole bunch of herbivores come through, they have a pressure on the vegetation, they eat a lot of the biomass, and then they move off for whatever reasons. And then the vegetation would bounce back because you haven't killed anything necessarily, you haven't lost any individual taxa, you haven't lost any guilds, it's just unchanged. Structurally, it's just maybe things got a bit smaller, and then they, with a little bit of time, will bounce back. So that, to me, is that first type of community shift, where you're basically looking at a biomass shift. However, if you continue with browse pressure, and this really speaks to something that Johan Bauer and has spoken quite a lot about passionately, it's not about animals, it's actually about human management of animals. And if that pressure is not alleviated, managed properly, and I think particularly in a droughty, highly unpredictable drought climatey thing, high pressure of herbivory with droughts, in that unpredictable drought moment, you can nudge the system, you push it through a transition. And that transition, to me, the first transition is when the vegetation gets opened up and the microclimate, its ability to hold its microclimate, to buffer microclimate, is lost. The vegetation starts to unravel a bit, and we start to see a loss of taxa, we start to see a loss of the perennial plants, so we're starting to lose guilds of plants here. You'll pick up the individual plants are very stressed. If you are observant of the vegetation, you will see that the papias are starting to get a bit, crinkle cut, whatever those things look like, chips, and the leaves, and the system is clearly under stress. You'll start to pick up as the vegetation shrinks back into itself, channelized soil erosion, but it's quite localized, and we've started to move into another state, which I've called semi-stable, because I think already at this point it's on a downhill track. And the reason why I call this a threshold is that the moment you lose the microclimates, you're in trouble. That system is already starting to unravel quite a bit. So this would be, to me, an example of what it might look like, something like this, where you're starting to get a lot more space, vegetation is not very thick, and that's just an impression. The second one would be where you move from that state down to an even more unstable, degraded state. I'm not actively using that word of degradation. To me, this is where you've lost the vegetation structure. You're no longer really able to call this thickets, in my mind. You might have a few remnant bush clumps that are hanging in there, but to a large degree, you've got a fire-prone matrix vegetation that's come in, replacing that the perennial vegetation. It's starting to track the stochastic climate, so your biomass is sort of all over the place. You've lost the structure that was holding the climatic buffering, and you've started to lose entire guilds. So at this point, speckboa might be sort of largely lost from the system. The succulent shrubs have all gone from the system. The trees are on their way out. The woody shrubs are really largely depauperate now, and you'll start to pick up extensive accelerated soil erosion. And this becomes the second major obstacle, is the fact that you're losing your topsoil. That is a very significant threshold to cross when you lose the topsoil. And then we go, oops, that would be a situation like that. Okay. And then the next, come on, this thing. The next and to me last major transition is when the tree component, that guild, starts to die out. It's an unstable situation. You're probably not even having to push it anymore. It will collapse by itself at this point. The vegetation is largely replaced with that fire-prone field layer, and it's a desertified ecosystem. So it would start to look something like this. You can see the amount of mortality just of the vegetation. The remnant trees are on their way out. So that's what I've looked at, made it look like. You've got a decreasing line that is showing all of your ecosystem services are collapsing, the functionality of the system is collapsing, and degradation is deliberately, I'm using that word deliberately, is going up. So our restoration efforts need to focus here on these, at this early stages. The sooner we can catch this process, the better. So this is where we would advocate planting, speckworm, trying to rebuild the structure of the vegetation, and trying to contain soil erosion where possible. It's possible potentially to get in at this stage also, where you've got high density planting of speckworm, grid-like planting of speckworm, deliberately trying to arrest soil erosion and to recover something of a good cover of the vegetation. But a significant point is this last block here. What do you do when the system has been so far pushed? You would be hard-pressed to call it thicket anymore. And I think we can be, at this point, there's flexibility to actually aim for something else. It might be too difficult to come back at a cost-effective manner. And rather we should be aiming for achieving what I've called a designer state, where maybe initially it's completely dominated by speckworm, because that does work as a restoration agent. But your goal here is to create a vegetation type, not necessarily aiming back to the original state, whatever that was, if you can even imagine it, but to create a state that has options for the future, where there's increased primary production, you've got some measure of ecosystem function coming back in, things like carbon sequestration and nutrient cycling and so on. And whatever happens to that in the future, whether you then add in other species or add in herbivores or do something else with it, you've created a state with options. Because these states here, I don't think you've got too many options. I think even from there, the ball is rolling down the hill, and it's a question of time before it degrades. So that's really what we're wanting to, this is my final slide. So we're wanting to have a restoration philosophy which really builds a pyramid here, starting with protecting the soil, stabilizing the situation, and rebuilding the microclimatic amelioration functions. That leads to an increase in primary production, infiltration and water use efficiency, that package of ecosystem functions. At that point, we start to get ecological function back. Reproductive cycles are moving on. Maybe other species are starting to come in through reproduction. Plant diversity rebuilds, and then faunal diversity, I think, will follow. To me, that's a logical process of restoration. Right. I will start to land here. Last slides. I have 3 Kit Kats. For the first person to identify what state are we in. Say it loudly. Severely degraded. State number 5. Right, I'll give it to you. I'm not going to throw it because I'll probably hit somebody on the way. Right, next one. State 2. I'll give it to you. Come on, guys. State 1. Come on, Alistair, you get it. But I don't know if you should be allowed it. The students, where are the students jumping in here? Last one. Ooh, you guys are harsh on this environment. 3. State 3. The point I'm trying to make, and I'll end with this, is that it's really helpful to try to understand for any one of the vegetation thicket types, whether you're in Sunday's Albany thicket or Sunday's arid thicket, to try and visualize the progression. And those states are not set in stone, they're gradients, and one could chop one out and add one in. It's really a body of thought to try to help you think about it. So I'm going to land there. False fact. Go on, Rika. Dry, hot winters. Did I? That was not a false fact. That was an error. It was more subtle than that. But you might get it. Let's see. Come on. Nicholas. Isn't it? That'll burn.
It will not.
Not? Good. Okay. You guys might be sharing it. It was neither of those. Those are two mistakes. Lynn. Okay. No, you guys, come. Okay. When did the Anglo-Boer War end? Smuts wasn't traipsing around here in 1905. The Boer War ended in 1902. So you guys get to share this just because you picked up 2 errors. I'll hand it to you now. All right, I'm done. Sorry.
Thanks very much.